Okay, hey everybody. Like Jarrell said, my name's Anna, and I'm going to talk about how to build xApps today. So there's a lot of ground to cover. I also have a portion that I can go over if we have extra time. Really, my goal today is just to help everybody build intuition about what a xApp is, what the components of a xApp are, how to design them, and really just set you up to start building your own if you're interested. Okay, so let's start with just the basics, like what is a xApp? xApp is short for cross-chain application. So a xApp is an application that uses cross-domain messaging channels in order to do things across chains. So let's take a step back. Like, we might not all have context on cross-domain messaging channels, what cross-chain stuff means. So let's start with building some terms. So a xApp is not a cross-domain messaging channel itself, crucially, and we're going to get into the distinction a little bit. So quick glossary of terms. So usually, if we're being super correct, we would say domains instead of chains. Why is that? That's because cross-chain messaging technology or cross-domain messaging technology can be used to send messages not just across layer ones, for example, like Celo to Ethereum or Near and Solana, but it can also be used for other domains, other environments that aren't necessarily blockchains or layer ones themselves. So, for example, like Arbitrum or Optimism, like optimistic rollups, side chains, layer twos, etc. All of these things need a way to pass messages in between them in order to interoperate. So throughout this talk, I'm going to use cross-domain and cross-chain interchangeably. I just want to establish what we're talking about here. Cross-domain is probably the most correct term. Cross-chain is a little bit more recognizable, so I'm going to err on the side of using that. And in the context of a given domain, everything is either local or remote. So for example, in the context of Ethereum, there are a lot of ERC20 tokens deployed locally to Ethereum. In the context, if I'm talking about Ethereum as a domain, Celo and the stablecoins deployed on Celo would be remote because they're on a different domain. So a channel or a messaging channel connects a local domain to a remote domain. And channels can be used to pass messages across chains. Messages encode arbitrary information that can be used to execute actions on chain. So these channels are basically passing bytes back and forth, but that doesn't really matter to us if the bytes aren't doing something useful. So these messages can be used to actually essentially send transactions or execute actions on chain in this cross-domain or cross-chain environment. xApps are built on top of cross-chain messaging channels in order to do stuff across chains. So xApps are applications, they're user-facing, and they utilize these cross-chain messaging channels in order simply to get a message from one domain to another. So what is optics? Optics is a new standard for building cross-chain messaging channels. So we're not going to go into the details, like the nitty-gritty about the design of optics in this talk. You can see my esteemed colleague Erin Hale's talk that she did on this stage yesterday about the flow of a message across chains using optics. We're just going to skate over it for this talk because what I want to focus on is the problems that optics solves for someone who's trying to build a cross-chain application. So what does this mean for developers? So right now, there are a few existing designs for cross-chain messaging channels. So like kind of three main types that I want to touch on right now are like light clients, custodial channels, and optics. And just kind of show the distinction between the two and why optics is kind of exciting development for developers. So optics versus custodial channels. Custodial channels are essentially cross-chain messaging channels that are run by an admin. And that means that they're trusted. The admin can arbitrarily attack the channel, send incorrect messages, and therefore steal funds, exploit any applications built on top of it. Essentially, to use a custodial channel, you need to trust the admin that's operating it. Optics, by comparison, is trust minimized. And we don't have to go too much into why we would want trust minimized stuff. I assume we have a solid amount of context on that. So optics versus light clients. Light clients are essentially running like full header validation of another network, another domain on chain. And this is the design used by IBC, for example. The problem with light clients is that they're complex and difficult to develop for new chains. So IBC, the design for IBC was released something like 3 years ago, I think, and it's just made it to mainnet now. Optics, by comparison, is modular and a highly reusable design that makes it a lot easier to deploy on new chains, basically. And it's basically a trade-off in the security model between a light client messaging channel and optics that allow us to kind of make these gains in simplicity and make it a lot easier to extend to new chains. So you can see my esteemed colleague James Prestwich's talk on ECC main stage, where he went into the exploration of the trade-offs when designing these channels and where optics kind of stands compared to some of these other designs. I won't get too far into it right now, but what I really want to emphasize is that this makes it radically easier to establish cross-chain messaging channels on a really diverse set of domains. So this means that we can basically spin up these channels on pretty much any chain that has like a smart contract language in a way that's very cheap, not a lot of developer hours to set up these new cross-chain messaging channels. So it's kind of a leap forward in our ability to interoperate across domains in a trust-minimized way. In the past, we would either have to trust an admin or basically kind of relegate ourselves within the Cosmos ecosystem, because right now that's sort of the only place that IBC works. We've also built in open source canonical implementations of the optics standard. So we made it really easy for anybody to deploy their own on-chain or off-chain components running optics. And we've also deployed our own, deployment of optics between Celo and Ethereum testnets, specifically Alfajores and Kovan. So that's live right now, and the team is actively working on it, shipping into it. But point being, optics team is solving the complex problem of passing messages between chains. And this means that xApp developers can write cross-chain applications using these communication channels. And yeah, they basically don't have to solve this problem. I guess you could think of it kind of like if somebody wanted to do something with a friend across the country and they had to set up the entire mail system in order to do that. That's a lot. Sometimes you just want to write a letter and get it where it needs to go. So we've solved that problem, and that makes it so much easier for xApp developers to actually just build on top of this infrastructure. Okay, I'm going to stop again for questions.
So let's say I wanted to develop like a push notification system. I could build that directly on optics and essentially run off or all of those chains.
So the question is, if you wanted to build a push notification system, could you build it using optics? So optics is operating between domains or chains, you might say. If you meant like on-chain push notifications, then sure. Yeah, you could absolutely build a xApp that would do that. And we're going to get further into like how you would go about building that xApp, building intuition around that, et cetera. But yeah, you can just really easily plug into this cross-chain messaging channel in order to build whatever application you want.
Do you have a rough idea when the Celo Ethereum bridge will be live on the mainnets?
Yeah, great question. So the team's actively working on it right now. We're in an unstable mode on testnets presently. Our approach as a team has been to ship quickly and iterate on testnets. So yeah, we basically built this pretty quickly and shipped it to testnets, and we're actively patching issues, hardening the system, working out the kinks right now. So I can't give you an ETA to mainnet, but soon TM.
Are there non-blockchain domains that the optics team is looking at?
That's a great question. So in terms of which domains that we are actually going to actively integrate with, what we know for sure right now is that the first messaging channel will be between Celo and Ethereum. Beyond that, whether we're going to go for layer 2s after that, whether we're going to go and add other layer 1s first, is a little bit undetermined. So I can't give a sure answer on that.
Maybe she's stuck on that. So, like, what is the minimum feature set requirement for change being there? Is that Bitcoin script enough? Is something as unexpressed as Monero like part of the team, or?
Yeah, basically a Turing-complete scripting language. We built this specifically to not use super like bespoke cryptography like client relays have to use. It's just a lot more extensible, and yeah, basically like we're using simple cryptography that should be widely available, and the smart contracts can be implemented on essentially any smart contract chain. Correct, yeah. Okay, awesome. Let's move on. Okay, so let's talk about what xApps exist right now, like what we can do with this technology, why you would even want to build this. So a great example of a xApp is a token bridge. So a token bridge is a xApp that enables users to pass representations of tokens across domains. So with a token bridge, we could transfer Celo tokens to Ethereum mainnet and trade your Celo tokens via Uniswap without any centralized counterparty. So right now, if I wanted to trade Celo for ETH, or Celo for DAI, or Celo for really any other Ethereum-based asset, I would need to basically use an OTC counter or a centralized exchange to do that. With a token bridge, that's not necessary anymore. With a token bridge, we can decentralize management of the on-chain treasury that's backing Celo-based stablecoins right now. So a lot of y'all might be familiar with CUSD, CEuro. These are signerage share stablecoins that are backed by a basket of cryptocurrencies. Currently, the cryptocurrencies in this on-chain treasury include ETH, include Bitcoin, and that necessitates right now centralized management of this treasury. With technology like this, we can actually have a decentralized, trust-minimized way of managing these on-chain treasuries that mix assets between chains. With the token bridge, we could even do something fun like making a permissionless testnet faucet. So for example, like I could send like girly ETH onto ETH mainnet and set up a Uniswap pool, basically, and like trade, basically buy like testnet ETH with like a little bit of mainnet ETH. So I wouldn't have to use like a Twitter authenticated faucet, which is rate limited, etc. So many things that you can do, fun. Okay, token bridges are currently the most widely demanded type of xApp, but they are not the only kind of xApp. So another example, optics contracts are actually governed by a cross-chain application, which controls the upgradability and other permissioned roles of the optics system. So all of the contracts in the optics system are upgradable using the upgrade beacon pattern. And the owner of those upgrade beacons is actually governed by a cross-chain application that was written for this bespoke purpose. So in this system, the optics governor role is located on a single chain, but it can execute upgrades to optics contracts on remote chains using this cross-chain application. So we can have this full cross-chain system that's actually governed by on-chain code. And the governor role can even be transferred across chains. So maybe the first governor is on Celo, and later it gets transferred to Ethereum. In the future, we can also decentralize management of the governor role, for example, possibly with a token-based voting scheme. And we could integrate with the token bridge to enable cross-chain token-based voting. So we can have this like fully decentralized system across chains using, like token-based voting. So with xApps, it's like, there should be the sky's the limit. You should be able to let your creativity run in thinking about like what you can do with this. Really quick, I will want to touch on a couple of limitations. I mean, cross-chain messages introduce asynchronicity to on-chain interactions. So interesting and useful xApps are definitionally limited to the set of problems that can be solved asynchronously. Like by definition, we cannot, in an atomic transaction on-chain, interoperate with another network. So you kind of have to like think in the problem set of things that can be solved asynchronously. So for example, something like an automated market maker in a cross-chain environment would face design challenges based on this. But something like a token bridge, for example, would work just fine. So now that we know kind of what types of things we can do with cross-chain applications, what this kind of looks like, I want to break down the components of a cross-chain application. And this should hopefully build intuition for any developers in the room who are interested in thinking about how they might develop their own. So xApps basically send and receive messages over cross-chain channels in order to do interesting things. You can kind of think of them as routers for messages across chains. And in order to essentially accomplish this goal, there's a couple of core components that basically most cross-chain applications that you'll see, especially built on optics, are going to have to have. So xApp has to encode and decode messages in a standardized format. So optics passes byte strings across chains. Byte strings are not particularly meaningful unless they're passing information that can be interpreted on the other side of the message channel. So a cross-chain application is going to define a format for encoding useful information on a local chain and then sending it across to a remote chain and decoding it on the remote chain. A xApp is going to need to address outgoing messages and authenticate incoming messages. So to do this, it will probably need to maintain some kind of permission set of deployments of the same cross-chain application on remote chains. And the reason for this is that you want to ensure, essentially, that any messages that the xApp is receiving have been executed with valid application logic on both sides of the messaging channel. And we can get into this a little bit more if we get to the building intuition part where we trace through like kind of this flow, this cross-chain flow. They need to send and receive messages across chains. Luckily, as we talked about, optics makes this easy. All you have to do is really integrate with a cross-chain messaging channel. Could be any cross-chain messaging channel. Could even be a configurable cross-chain messaging channel. Optics is a great option. And then finally, a xApp is going to need to enact application logic locally. So this is the only component that really depends on the application. And this is kind of where the design space really enters if you're building your own. So how to build your own xApp. Like, I've made this as easy as I can, hopefully. So a couple of things. So first off, what's really important is building intuition about the design space in cross-chain applications. So how are you going to do this? You could review this talk. You could look at some existing code. A great way to do this, you can start with some of my code examples. I've written some code examples that are specifically meant to be instructive for developers who are interested in building these types of applications. So I wrote a xApp template, which implements like a forkable template of these xApp components we just went over. It can be easily copy and pasted, basically, and then filled out the application-specific components. So you can basically use this as a starting point for building your own xApp. We have a ping pong xApp. This is fun. It's like a toy example of a xApp, and it's meant to illustrate the aforementioned dynamics of passing messages across chains. So the ping pong xApp basically, it'll send a ping to a router across the chain. If it receives a ping, it'll send back a pong. If it receives a pong, it'll send back a ping. So it's basically a trivial example xApp that's meant to help build intuition and illustrate what it looks like to send these messages across chains. Okay, stepping up a level in intensity, we've got the token bridge. This is implementing like a real useful xApp And this will hopefully build intuition for the design space for application-specific logic of these applications that are operating across chains. And yeah, so this is when we're getting into the realm of like, we're doing real stuff. And then finally, there's the governance router. It actually riffs on the original template to accomplish an even more specific and bespoke goal. So this is like the final level of complexity of xApps I've implemented right now. I'm going to include links to all of the code for these in this presentation. So if you acquire this presentation, you can go and actually take a look at the code for these, fork them, read through them, build your intuition. And I'll also include a link to just the optics monorepo at the end of this talk, which you can explore like the implementation of optics itself, as well as all of these cross-chain applications. Okay, so after you've built your intuition, you just need to design your application logic. This should be easier once you have a better understanding of like what it looks like to build these applications. Again, building that intuition. Next, define your message format, define what type of messages you need to send across chains, and encode a format for how to basically coerce that information into a byte string. And then finally, just, yeah, write your xApp. Like, you can go fork the template that I talked about before, and pretty much all you're gonna need to fill out within that template is your application-specific logic and your message format. So hopefully this has made it, you know, a bit easier to understand like what this looks like. And yeah, those are kind of the steps you would take to write your own. Yeah, I'm excited to see what people start building on top of this. It's a kind of exciting design space. So yeah, I'm pretty stoked about this. So I'll pause for questions. I have an overflow section that we can get into. I have also other stuff that we could do based on what folks are interested in. But yeah, let's pause now for questions.
What are the differences between a DApp and a XApp?
Yeah, so DApp is kind of a loosely defined term, but generally speaking, it tends to mean like essentially an on-chain smart contract and sometimes a Web3 connected off-chain application, user-facing application. And generally, a DApp is deployed within the context of a single domain. DApps do not suffer from this design challenge of asynchronicity. And yeah, generally, DApps are deployed in one domain, whereas a xApp would be a cross-domain or cross-chain application.
Are there other cross-communication standards that allow for synchronous sort of application designs?
Are there other questions? Are there other cross-chain messaging channels that allow for synchronous communication? Yeah. So no, that it's unfortunately not possible because yeah, domains like chains basically have deterministic synchronous code that's executed within a kind of walled execution environment. So like the EVM, for example, for Ethereum and other EVM-based chains. And those EVM, those execution environments cannot communicate with outside chains. So that's basically why this is even a problem. This is why like we have to build new things to do this, is we need to like figure out how we can break down the walls between these execution environments and actually communicate across chains. Yeah, it's a good question though. Yeah, yeah. Oh, back there.
Hey, so what is, I guess, the plan to integrate with other chains and what would that really look like?
Yeah, so like I said, right now, like I know less about the kind of go-to-market or BD aspect of which chains and which domains will prioritize first. What I can say is that we are starting on Celo and Ethereum. We're live on testnets right now, and we're going to be going to mainnet as soon as we can. We have smart contracts implemented for any EVM chain, so it'd be really, really easy to like redeploy these same smart contracts on any EVM compatible chain. But this is not limited, like specifically and crucially not limited to EVM compatible chains. you can implement these smart contracts. It's a pretty simple set of logic that you could implement and deploy on any other non-EVM compatible chain like Near, Solana, et cetera, et cetera. So does that answer your question? Go. Yeah.
Yes.
Oh, okay, cool.
So, there's certain, like, which verticals do you see xApps being most applicable for? Like, primarily DeFi, or maybe it's NFTs? I would assume that there's a lot of, like, good use cases for cross-chain communication. I mean, video game, like gaming and whatnot.
Yeah. That was a great question. I mean, so NFTs, it's an interesting question. I think James had a great point about this on the panel that he was on yesterday, which is that essentially like NFTs are kind of, at the end of the day, like a social coordination mechanism. Like they're useful and interesting if and only if we agree upon the canonical sort of deployment of where this ownership lies. And that's not an on-chain thing, that's a human coordination issue. So you could send NFTs across chains. We'll see if people are really doing that. It's less of a sensible, I'd say, like implementation than, for example, like a token bridge. I think like what I'm really excited about is to see what other folks come up with in this design space. Like right now, I've been building on this for a couple months now, and it's honestly a lot of fun, like building these applications. It's really interesting new kind of design paradigm as someone who has written some stuff in like the DApp, like single domain realm as well. And yeah, it's kind of, xApps aren't really a thing right now. I coined the term, because these cross-chain messaging protocols are not very accessible and they're not very like widely deployed. IBC like just made it to mainnet like recently. So it's kind of like we haven't gotten to the zone where people are starting to really think about this yet. And I'm pretty stoked for other people to kind of get creative with like what this looks like. Yeah.
As you've been building out, this foundational tech, do you see a lot of other engineers starting to like wake up and start building out cross-chain, or are you still feeling like you're in a niche zone?
Definitely still feels like a niche zone, I would say. But I got my first inbound the other day from someone who was like, I want to build a xApp. It's going to be called WorldCoin. Or something like that. Like they were having like a cross-chain coin. I was like, awesome. So I like linked them to all of my templates and stuff. We're gonna have like developer docs that'll be more widely accessible, so I don't have to like, like copy and paste links every time somebody asks me about this. But thus far, I have exactly one person who has asked me about it. So hopefully more after this talk. Okay, cool. So yeah, what? Oh, question.
What's the best way to familiarize with the design of optics? Is it the Celo docs, or is there something different?
Yeah, so honestly, right now we're working on building out our developer documentation. It's going to get a lot better than it is right now. What you have right now is basically the optics monorepo, so you can read the code. There's not as much written documentation. We do have a page or two up in the Celo docs that kind of go through the design space of optics and a couple of things that we've talked about today. But at this time, we have not really built out our developer documentation. So honestly, like some of the talks that my teammates have done at ECC, Aaron, James, Connor, have all done talks on this, and those are some great ways to learn more about that. Otherwise, like the code is all open source, but we're working on more docs. Yeah. Okay. Cool. Yeah. If folks want, I can go through like building intuition, like what the token bridge, how it's designed, or I could take folks through some code, or I could just rap. We could get drinks. Prenee's like, go over it. Barbara's like, drinks. Do folks want to go through like the, pardon? Okay. All right, we're going to go through the bridge. Let's do it. Okay. So yeah, so I kind of went through these components of a xApp, and I want to put it together into a flow that will both kind of illustrate like how the highest demand existing xApp is built, and this will hopefully also build some intuition for like the design space of cross-chain applications. So yeah, let's walk through it. So basically, like I said, these xApps are routers that are sending and receiving messages across chain. So it's kind of like a mirror image of what you're doing on the send side and what you're doing on the receive side. So I'm going to walk through both, first in the general sense, and then I'll do it in the token bridge specific context. And this will hopefully be interesting, and like maybe some light bulbs will go off for folks. So when you're sending a message, basically these xApps will be triggered on chain by a user. It could be an EOA, could be a smart contract integrated with the xApp. The first thing that the xApp needs to do is execute application logic locally. So again, this is the component that really looks different depending on what application we're talking about. The next thing that it will do is construct a message in the predefined message format that basically encodes this information into a bytes string. Next, it'll figure out where it's going to send this message. So again, that permissioned set of xApp routers on remote domains, it'll do basically a lookup in a mapping and get the domain and address pairing of the xApp router on the remote chain that it needs to send it to. And then it's going to just ping that message across the cross-chain channel, presumably via optics. So application logic, construct a message, address the message, send the message. On the receive side, it's literally just the flip side of the send. So first, it's going to receive a message along the cross-chain channel. Then it's going to authenticate that the sender was a remote xApp counterpart. When I get to the application-specific logic for the token bridge, it'll make more sense why you need to actually authenticate these messages, hopefully. But it'll basically, again, do a lookup to see that the sender of the message is actually a deployment of this xApp on a remote domain. Deconstruct the bytes message using the predefined format that it knows the other xApp router is using. And then finally, execute application logic locally. And these first three steps, receive a message, authenticate, deconstruct, like that's xApp generalized. And then the execution logic is going to be like more specific. So within the context of a token bridge, let's talk about like what this looks like. So essentially, if I'm trying to send my Celo from the Celo network to Ethereum, I would basically ping this token bridge xApp. And the token bridge will pull my Celo tokens and hold them in escrow in the router. So those tokens are now basically locked up in the router contract. Then that router contract will encode a message saying, I'm sending this amount of Celo to this address on this chain. It will get the address of the xApp router on Ethereum and send that message to the xApp router on Ethereum. On the flip side, the xApp router on Ethereum will receive this bytes message, deconstruct it. This is why we need to authenticate the sender. So imagine that we didn't ensure that the xApp router was the one sending us these messages. Anyone could ping a message across this channel and say, I'm sending 100 million Celo to myself on Ethereum. And then they could basically like print money. What the xApp needs to know is that those tokens are actually being held in escrow in the router contract on the originating chain. And the only way it knows that is if it authenticates that this message is coming from another xApp router. So it'll receive this message, authenticate it's coming from another xApp router, deconstruct it, and say, okay, I'm receiving 100 Celo, and I'm sending it to this person. At that time, it'll deploy a representation ERC20 token, if that doesn't exist already, and mint those tokens to the recipient on this chain. So then basically putting that whole flow together, you've taken Celo that you had in your wallet on Celo, sent it to a xApp router contract where it's held in escrow. Then the remote xApp router mints a representation of that Celo on Ethereum. And then you can basically send around, trade, use these Celo representation tokens, knowing that you can always send those tokens back to Celo, the main chain, and receive that Celo that's held in escrow. So on the flip side, if somebody's sending Celo from Ethereum to Celo, they would burn the representation token, send a message to Celo mainnet, and that would unlock the tokens in escrow. So this way, like, the token supply is never inflated. A representation token on a remote chain is always, can always be traded, basically, or unlocked for the actual canonical asset on the originating chain. And so yeah, it's basically this simple design that just locks up these tokens, mints representations, burns them, and unlocks them on the flip side. Does anybody have questions about that? Yeah.
So because the two router contracts and the domains cannot natively speak to each other, who or what is actually initiating the message passing?
Yeah, so if somebody wants to send tokens, they would call into the xApp router contract, and they would provide the address that they want their tokens to go to on Ethereum. So just like any other smart contract, these contracts are triggered by users. xApps are user-facing applications. So anyone who wants to send their tokens triggers the router to send their tokens and then receive them on the other chain. Does that make sense? Two transactions are necessary. The initiating transaction is sent by the external-facing user. The dispersed transaction on the remote chain is handled by an off-chain actor in the optics system. And that gets a little bit more into the actual design of optics, how that works. So Aaron's talk is a great resource for that. We'll have developer documentation coming out soon. And then also Connor's talk is a really good overview of how we're operating these off-chain agents, like the deployments of them, et cetera. There's a significant off-chain component to this system because there has to be the relay of these messages between networks. So yeah, like, yes. Yeah.
If I send Celo to Ethereum, do I need to pay fees on Celo or on both sides on Celo?
Yeah, so the originating transaction on the originating chain, the external-facing user will pay those fees. The dispersed transaction on the remote chain would be paid by what's called a processor, an off-chain agent within the optics system. What you might notice, based on that question, is that fees are significantly cheaper on Celo than they are on Ethereum. So it's a lot cheaper for example, a user to send tokens from Celo than it is for the optics system to disperse those funds on Ethereum. And we have some designs to basically mitigate spam. This is an issue across any domains with a differential in cost to execute transactions. And essentially, we've designed these off-chain agents so that they can be kind of application-specific payers of these fees. In the future, we're going to figure out a way to basically incorporate incentives into operating these off-chain agents and like operating the optics system writ large. Right now, the main incentive for operating optics as a system is just you want messages to go across chains. So it's like you want to use optics. And so you're willing to pay these fees. In the future, there will be more incentives to kind of like have decentralized actors actually playing these roles in a way that's not just sort of like altruistic to kind of prop up a public good. Yeah. Any other questions about the token bridge, optics? We're good? Yeah, it depends on the domains because essentially you need to reach finality on really both chains. So it's a matter of how many blocks until you reach finality and the block time on a given chain. So yeah, depends. No, or like not one that I can like cite right now. I mean, like for example, like Celo is a proof of stake chain which reaches finality instantly and has a block time of what, like 5 seconds? 5 seconds. Ethereum is currently a proof of work chain which requires several blocks to reach like reasonably high confidence and finality, and the block time on Ethereum is about 15 seconds. So yeah, hopefully that elucidates. Oh.
Is there a delay at all between sending and receiving messages?
Yes, it would be the delay to basically, I see what you're talking about. That's my teammate, guys. We have a plan. Yeah, so there's actually a fraud-proof period on both chains. Optics stands for optimistic interchain communication, so or optimistic interchain. And it's basically that trade-off in the security model in exchange for more simplicity is basically using like optimistic type dynamics to basically pass these messages across chains. So similar to like an optimistic rollup, there's somebody who basically makes a claim about what happened, and then there's a fraud-proof period where that claim can be proven false. So there is a latency on the receiving chain related to this time lock fraud-proof period. Yeah.
How do you deal with congestion on mostly Ethereum in this? Is there a chance that a message can get rejected or a transaction can get held up? How does that affect the Zap?
Yeah, so our off-chain agents are the ones that are responsible for essentially submitting all of the transactions responsible for making sure this message gets relayed across chains. And those off-chain agents have some like error handling logic for if a submitted transaction doesn't execute. They'll retry it, essentially. Similar to like any transaction that has to submit, or sorry, any application that has to submit transactions on chain. You're not guaranteed that it's going to go through because distributed systems and blah. Yeah.
Is there some protection against front running?
Front running.
I mean, if someone would send a transaction making some money on the other chain, and you can just go to the source chain.
Yeah.
Do these,
Yeah. So great question. Actually, James recently did a panel on cross-chain MEV, moderated a panel on cross-chain MEV, minor extractable value, at, what was the name of that event, James? Oh, geez. MEV.W2F, and that's recorded, so you can go look at that. I would have to say this is not like a particular area of expertise for me, but because there is this increased latency in passing messages between chains, like it's a real thing that needs to be considered. Yeah. Oh my God, we're so hiring. We're so hiring. It's crazy. Yeah. Talk to us afterwards if you're interested in working with us. All right, thanks everybody.